Hello students. Today we'll be discussing the cardinality of the irrational numbers. This is a continuation from our last video on the cardinality of natural numbers, whole numbers, integers, and rationals, and this topic is meant for students at around the grade 9 level. So last time we showed that the cardinality of naturals, whole numbers, integers, and rationals are all the same. But we left out the irrationals. Why is that? Well, there's actually more irrational numbers than there are any of the other numbers. In fact, there's more irrational numbers between 0 and 1 than there are natural numbers on the whole number line. Pretty surprising, right? Well, we can demonstrate this fact using a very famous argument called Cantor's Diagonal argument, which we'll do on the board. So what we're going to try to do is we're going to try to create a one-to-one correspondence between the naturals and the irrationals between 0 and 1. So first, on the left, I'll list all the naturals starting from 1 all the way to infinity. On the right, I'm going to be listing irrational numbers, which are infinite non-repeating decimals, randomly all the way down. So here we have an countably infinite number of natural numbers and a countably infinite number of irrational numbers. Now, what I'm going to do is I'm going to construct a new irrational number that does not appear on this list. The way to do that is we look at every single digit, the first digit of the first number, second digit of the second number, third digit of the third, fourth digit of the fourth, and so on, and change those digits and then turn them into the new number. So what do I mean by that? Well, the first digit of the first number is 3, so we're going to turn it into a 2. Second digit of the second number is an 8, so I'm going to turn that into a 9 up here. Third digit of the third number is a 7, I'm going to turn it to a 5. Fourth of the fourth is a 9, I'm going to change that to a 0, and so on, so on, so on. I'm going to do this for every single number in the list, and once I reach the end, I'll end up with a number up here that's different from every other irrational number in this list by at least one digit. So what this means is I've created a new number that's not on this countably infinite list of numbers. So this can only mean one thing, that there's more irrational numbers than there are natural numbers. And in fact, I could do this infinitely many times, and that'll create infinitely many more irrational numbers. So there we've shown that there's more irrational numbers than there are natural numbers. And this argument extends to the real numbers as well, since the real numbers includes the irrational numbers. And this argument can also be applied to all irrational numbers, not just irrationals between 0 and 1. And finally, to clarify some terminology, when I refer to the way countable infinity refers to the number of naturals or wholes or integers or rationals. It's basically a number of countable numbers there are. So if I can list the numbers down a line, it's countably infinite. However, if it's like the irrationals where I really cannot list them down in a line, that's uncountably infinite. And there's many more uncountably infinite irrationals than there are countably infinite naturals. That's it for this video. Thank you very much for watching this video and for watching this series.